All right, students, welcome back. This video, we're going to cover lesson 11-9. This is density. This is the final lesson in the book, the text, whatever you want to call it. I'll do another video, the study guide for 11. I might go back and do one for study guide for 10 because I have folks that haven't taken the test, and we're just over 2 weeks from the EOC, so anything we can do. And for you guys that are pushing, I appreciate you guys. If you're not in my class and you're pushing, I'm sure your teachers appreciate it, but I appreciate it too. And if there's anything I can do to help, let me know. I'm going to stay after for tutoring a couple of days this week, so please come see me if you're not in my class, or if you are in my class, obviously come talk to me or send me a message and focus. Looking at Wednesday and Friday. So anyway, so 11-9 density, we got GR 4.4. We're going to solve problems using area to find density, and GR 4.5, we're going to use volume to find density. Excuse me. Let me see. We got some flickering lights here. Okay, a little better. Sorry, y'all. I'm a one-man studio here, so, doing what I can. All right, so density based on area. So density is the measure of the quantity of some physical property per unit of length, area, or volume. So two types of densities we're going to talk about is population density. So let's talk about it first. Population density is the measurement of population per unit of area. And its density is the number of objects divided by the area. Examples, people over, square miles. I think we have a question about cows. Just be whatever. So number of objects, and then the area is going to be square miles or whatever, something to that effect. All right, so over here, based on density based on volume. All right, so density is the measure of the quantity of some physical property per unit of length, area, or volume. If two objects have the same volume but different masses, the object with the greater mass will be denser. All right, so when you're doing density based on weight or mass, its density is mass or weight divided by volume. And the problems we're going to have, they're going to give us the weight. They're going to give us, the info to find the volume. We find the volume and then divide the two. It's always going to be, or most of the time, it's going to be some sort of decimal. You'll see. So moving here. So I'm going to put example 1 and example 1 check together. So you guys are going to deal with some volcanoes. And here's your square miles. So you're going to divide those. And it kind of tells you here, is it, it's volcanoes over miles squared. And you should get one of these 4. So it's going to be number of objects over area like we had. So I'm going to go ahead and write that. So density equals, and I'll draw my line. So example 1, the World Bank reports that the population of Greenland in 2015 was 56,114. All right, so hold on. We're talking about people. And I'm just going to 56,114. And we're talking about space, but let's see what unit. So if the total land area is about 86,000 square miles, so this is going to be, you can put area, I'm going to put miles squared or square miles, same thing. So it says 836,000. Hopefully I said that right. Now I'm doubting. Okay, let's scoot over. So do some more calculator lessons. I'm going to try to do a video. It won't happen tonight, but I'm going to talk about the reference sheet and the calculator. I may do a live video, and any of you guys tune in if you're in my class. I'll give you some extra credit. If you're in one of my other colleagues' classes, I'll give you a high five. And ask them to give you extra credit. How about that? So 56,114 divided by 836,000. One more. There you go. All right, so it gives us 0.067 1, 2, blah blah blah. We're gonna go zero the thousandths. So, and I'm doing this because there's something later. So remember, the first place from the 0, that's tenths. Next one's hundredths. The 7 would be the thousandths. So when we're gonna go to that, I think. Well, I think it's on the next page. So the 0.67, and this would be people per square mile. So 0.67 people per square mile. All right, so down here tells you volcanoes and square miles. So it works the same, and you'll get one of these 4. So good luck to you. We go to the bottom of the page. All right, there we go. Bottom of the page. All right, so example 2. Masha has a farm with 220 milking cows. All right, so this one's going to throw us a little bit of a curveball. Just hold with me. But let's go ahead. You guys make a habit. Now, I know when we take tests online, you can't do this. Well, I say that. I believe McGraw-Hill lets me, I know it lets me allow you guys to cross out answers. Let me see if it allows you to highlight. Don't know about performance matters, and definitely don't know about the state test. But, you know, if you can highlight, now if you're, you know, taking the state test, you have that scratch paper. So, you know, if this is number 30 something, you know, on my scratch paper, I'm going to write that. Excuse me. And, you know, write that down, 220 milking cows. Anyway, so these ladies, produce 286 pounds per acre. So, yeah, we're going to keep highlighting. So they produce 226 pounds per acre for a total of 1,412,840 pounds of milk. That's a lot of milk. So, due to recent regulations, Masha must pay a fee if she has more than 30 cows per square mile on her farm. Determine whether she's going to have to pay the fee. Hint. Sorry if you hear my kids yelling in the background. So the hint is that 640 acres make a square mile. So, so that'll give me a chance to, again, hopefully you guys are listening and not just taking the notes. And for you guys that do listen, thank you. Seriously, I hope it pays off after you take the EOC. You know, and hopefully you guys hear this, because I know some of the honors classes may not get through the book, but you know, if this helped, please let me know. It's just nice to know, you know, that it did something, you know. So let's see. All right. So first off, let's just say, because we need to know if density is greater than 30. So that tells us, you know, if there's a fee or not. Okay. And the density is cows over acres. Wait, wrong. Square mile. So we'll just do miles squared. Okay, now, so we know how many cows. We can just set that up right here. There are 220 cows. That's easy. Now, how big's their farm? I'm going to give you guys just a second. Now, if you were in class and you've already went over this, obviously, hopefully you heard what I said. If not, hey, that's cool. That's why the videos are here. I have another colored pencil or something that... Oh, well. Okay. So we're going to just kind of separate here. We need to know how big is the farm. So we're looking for farm size. And we need to know in square miles. So here's how we're going to do that. Step one, we know, so yeah, the 220 cows, that's fine. That goes here. Forget all that beyond that. We know that those cows produce that 286 pounds per acre. And we know the total is 1.4 million. So farm size is going to be the total milk divided by pounds per acre. And this is going to tell us the farm size in acres. So then we need to convert it to square miles. So the next step will be, it told us that 640 acres is 1 square mile. So first we're going to do this. Keep putting this down like I'm going to find another pen. Hang on. My wife's been working in here. Does she have a blue or black pen? Yeah, because... Sorry, and if the audio gets bad when I look for something, it's because I'm not in front of the microphone. I'm trying to make an effort here. Okay, so total milk divided by pounds per acre. Total milk is 412,000. So 1,412,840. Okay, making sure. Whew. And then it's divided by 286 pounds per acre. Okay, so 1,412,840 divided by the 286 pounds per acre. So that tells us that her farm is 4,940 acres. All right, so let's just set this aside. So for every 640 acres, it's a square mile. So acres per square mile, we divide acres, total acres, by 640. And then it'll tell us how many miles squared. So total acres was 4,940. I'm not going to rewrite it, or well, actually I will. I'll do it. So 4,940. So you guys know. So 4,940 divided by 640. So her farm. Let's see. We'll go 7.72. See, it's 7.718. So we would just round that up to 7.72. And I know I said thousandths, but it really won't matter because, well, you'll see. All right, so now, how much in miles square? 7.72. So now, calculator. So cows, 220. That hadn't changed. And then the farm is 7.72 miles squared. So she has, drum roll please. Sorry. So it's going to be 28.49 cows per square mile square. So here. Now, it says that density had to be over 30. Well, that's less than 30. So no fee. That's really the answer. Does she have to pay a fee? No. But you had to do all that to figure that out. So if you ever own cows, that may come in handy. My wife would love to own cows. It's the only time she's allowed me to talk about geometry in the last 3 years that I've been teaching, because the question had cows. But she didn't even know the density. She just knew they had cows, and then she was done with it. So, she has that choice. You guys will have that choice after 25 more school days. So anyway, backside, example 2. This one's going to be simpler and it's for you guys to do, but if you're listening, you'll you'll get the answer. So, Adeline is planning to fill a pool with water and then float a layer of numbered rubber ducks on top. She knows that it takes 25 rubber ducks to fill 1 square foot area. So you want to write over here 25 ducks per 1 foot square of area, square foot of area, so foot squared. Pool used at the carnival had an area of about 7 square feet. So the area is about 7 feet squared. How many rubber ducks? So to find out total, it's going to be you're basically going to multiply ducks times area. Because it's 25 per. Yes, well, I worded that a little wrong. So it's the total ducks needed. So it's going to be 25, the 25 ducks, and then however much the area was in square feet. Hint. So I'm going to move up here, but if you're still listening, not just taking notes, you'll hear that it's simply 7 times 25. You have 7 square feet, 25 per square foot, so just multiply the two numbers. Easy peasy. All right, example 3. Antonio opens a brick of clay that weighs 25 pounds. So let's just say clay, 25 pounds. And so part A, what's the density? So density is going to be the weight over the volume. So this is one where we're going to come over here. We're going to find the volume. So, but let's see what we got. So, and B, so what is the density of the brick of clay? So density is going to be the weight over volume. This is the brick. So this is a rectangular, let's see. Yeah, the brick's going to be like it's a rectangular cube. It's going to be like this. You can't really see because it's so dark. I hope this might help some. It'd be a solid, then it'd be like a dotted line. And you guys know my drawing sucks. So anyway, volume for this guy is going to be base area times height. This is a rectangle. A rectangle's base area is length times width. So it's this is how tall, so that's the height. This is how wide, and this is how long. So it's 9 times 6 times 10. So 9 times 6 is 54, times 10 is 540, and this is inches cubed because it's volume. So now we have 2 numbers to work with. They told us it weighed 25 pounds, so it's 25 pounds over, let's see, yeah, just ask for the density, over, so it's 540, 540 cubic inches. Where did my calculator? Okay, excuse me, yeah, 25, okay, making sure. All right, so 25 divided by 540. So 0.046. See, the 2 next to it is not bigger than 5, so thousandths would be 0.046. So density 0.046. So that finishes off part A. So part B. He uses the same clay, so still 25 pounds, to make a foundational cube for a sculpture. If the cube weighs, well, okay, forget the 25 pounds. If the cube weighs 1.3 pounds, what are the dimensions of the cube? Okay, so a couple of things we need to know about a cube. So a cube, and man, help us because I'm drawing here. Yeah, I'm terrible. So, imagine if you will. So a cube is made up of squares. It's, square base, square sides, square everything. So to find the perimeter, it's 4 times the side because the sides are equal. To find the area, it's side squared because, again, the sides are equal, so side times side. So the volume it would be like length times width times height. Well, everything's the same because it's a square. So it's square side cubed. This is important information because we're wanting to find, they want to know the dimensions. So we're going to find the area, and then we're going to take the cube root, not the area, excuse me, the volume, and take the cube root to find the sides. So we got the density. So let's go here. So density equals weight divided by volume. So how did I do this to make it the least complicated? So So I can see doing it a couple of different ways. I'm trying to think of the best way to. So we have the weight. Well, it's fine. We're gonna end up doing. So we already know the density is this, but we're gonna use the fraction, and we're gonna cross multiply. So we're gonna take this guy, and then over here we don't know the volume of the cube, so we're going to call it x. And we do know the weight. He says that the cube weighs 1.3 pounds. We were dealing with, let's see, pounds here. So, okay, pounds here, just making sure we don't have to convert. We didn't. Okay, so now, hang on. We ended up having to cube this, I thought, but well, let's just do this. So 25 times x, 25x equals, so 540 times 1.3 is 702. Let's divide both sides by 25 and see if I get the right answer. If not, we may have to play with this because, all right, so 2808. Okay. Yeah. So the area or volume, of the cube, I'm going to put volume, just put under here cube, is 28.08. All right. Let me move this over. Now, so the volume is the side cubed. So in order to find the side, because volume equals side cubed, we're not going to keep writing this, but so side cubed equals 2808. I know I said it and said we weren't going to keep doing it, but it's just habit. We're going to take the cube root so that we can get the side. I'm going to find, well, so I've told you guys, and we'll do this in another video. So we got 2808. That's what, all right, 2808. We need the cube root. So we talked before about this. If we needed to cube something, we square it here, but if you need to go a different exponent, so to the power of 3, that's what cubed is. To the power of 4, either way, you would use this. So to go backwards, you see above my thumb in the green is something square root, but it's x. The x is what we're filling in. We're going to cube root it, so we want that to be 3. So we would hit the green button to make this. So now we're telling it we want to take the root, but what root? We want the cube root, and then we're going to hit equals. And it's 3.039, we're going to just round it up and say that the side is 3.04, and that's in inches. So if he takes this clay and redoes it into a cube, each side would be 3.04 inches, based on the density and all that good stuff. I know that's a lot. This is definitely a level 5 question. The example one, example 3 check. You have a part A, part B, so you're going to find the density of the soil, and it tells us the planter looks like a triangle, but I could have swore I read something about a trapezoid. Maybe it was. So let you guys work on that. If you need help, let me know. Send me a message in Focus Teams or comment on the video. But this finishes off the text for the geometry course. Like I said, I will do another video on the study guide and the reference sheet and the calculator. After that, again, if you guys still listening, and I'm sorry I'm rattling, I'll hush in just a second. But at the end of this school year, this will conclude my time at First Coast. For any of you guys, I've enjoyed teaching you. I hope you've learned something. Gonna have a yearbook. Come by and sign it before the end of the school year. I'd like to be able to say goodbye to you guys before I head off to the next school, which is where my daughters go. I'm not gonna say because this is YouTube. So anyway, until next time, have a good night.